In this video, we learn about linear first order differential equation. A linear first order differential equation has the form of dy dt plus p of t times y is equal to g of t. And so here, the main feature of a linear first order differential equation is the coefficient of dy dt is 1 and the dependent variable y is being multiplied with a function of t, that's p of t, and the right hand side is a function of t, that's g of t. To solve a linear first order differential equation, we use a method called the method of integrating factors. So now here is how we use the method of integrating factors. Number one is to put the differential equation in the form of dy dt plus p of ty is equal to g of t. So here the coefficients of dy dt must be equal to 1 and the dependent variable y must be multiplied with a function of t, and the right hand side should be a function of t. Then the next step is to compute the integrating factor, which is giving us mu of t is equal to e exponent the integral of p of t dt. The third step is to multiply through the differential equation by mu of t. After we are done multiplying through by mu of t, the left hand side of the resulting differential equation will be of the form mu of t y of t all prime. Then the fourth step is to integrate both sides. Then the fifth step is to solve for y of t. With our first question, we are to solve the differential equation dy dt plus 3y is equal to 5. We have to compare our given differential equation to the standard first order linear differential equation, that's dy dt plus p of t y is equal to g of t. And so here we check, is the coefficient of dy dt 1? And that's yes, because here we have the coefficient here to be 1. And also here we have here to be y and here to be y. So which implies that our function p of t is giving us 3 in this case, right? Now we move on to the right hand side. So right hand side, g of t in this differential equation is going to be 5. And so we have p of t is equal to 3 and g of t is equal to 5. Now let's compute our integrating factor. Mu of t is giving us e, then the integral of p of t dt. And so we are going to have e integral of p of t, which is 3, then dt. As the integrating factor will be giving us e 3t. From step 3, we have to multiply through the given differential equation by mu of t. And so we are going to have e exponent 3t multiplying dy dt plus 3y is equal to 5 e exponent 3t. As we saw from the solution procedure, the left hand side will always be simplified to mu of t y all prime, right? So in this case, we are going to have it to be e exponent 3t y of t all prime, and this is equal to 5 e 3t. We just have to integrate both sides, and so you're going to have the integral of e 3t y of t prime. So here we're integrating with respect to t, then we do same to the right hand side, so 5 e 3t dt. Now since the integral operator and the differential operator are inverse functions, these two guys will cancel out, right? And so we are going to have the left hand side to be e 3t y of t. Now we have to integrate the right hand side, and so the right hand side will be giving us 5 on 3 e 3t plus a constant c. And so from step 5, we have to solve for y of t. So we are going to divide both sides by e 3t. So that's we're going to have y of t is equal to 5 on 3 e 3t divided by e 3t plus c divided by e 3t. Thus y of t is equal to So here this guy will cancel this guy, so you're going to be left with 5 on 3. 5 on 3 plus c e minus 3t. With our second question, we have to find the solution of the IVP t squared y prime plus t times y is equal to 1, where t is greater than 0 and the initial condition is given as y of 1 is equal to 0. And so our first step is to compare our given differential equation to the standard form of the first order linear differential equation. And so we must have the coefficient to be 1, but here we have the coefficient to be t squared, right? So we first have to divide through by t squared, and so we are going to have y prime plus t divided by t squared y is equal to 1 on t squared. This simplifies to y prime plus 1 on t times y is equal to 1 on t squared. And so here we have the coefficients of dy dt, which is y prime in this case, to be 1, and we are going to have our function p of t to be 1 on t and g of t to be 1 on t squared. So thus our function p of t is going to be 1 on t, and our function g of t, which is the right hand side, is going to be 1 on t squared. Our next step is to compute the integrating factor mu of t. So we are going to have mu of t to be equal to e integral of p of t dt, and so we are going to have e integral of p of t is now 1 on t dt. Now what's the integral of 1 on t? That's ln of t, right? So we are going to have e ln of the absolute of t, and so our integrating factor is equal to t. We got t because e and the natural log function are inverse functions, and so these two guys will cancel out, so we are going to have t. Our next step is to multiply through the differential equation by our integrating factor t, and so we are going to have t multiplying y prime plus 1 on ty is equal to t times 1 on t squared. The left hand side will always be equal to the integrating factor, which is t in this case, times our function y of t, all differentiated with respect to t. Then is equal to, this will cancel one of these, and so we are going to have our results to be 1 on t. Now we integrate both sides, right? So we are going to have the integral of the left hand side, which is t y of t all primed. So we're integrating with respect to t is equal to 1 on t dt. And so the left hand side is going to be t y of t is equal to, when we integrate 1 on t, we're going to have ln of the absolute of t, then plus a constant c. So our goal is to find y. So we are going to have y of t is equal to ln of the absolute of t divided by t plus c on t. We had our question to be an IVP, that's y of 1 is equal to 0, and so we must substitute in these points in order to find our constant c. So when t is 1, y is equal to 0, and so we are going to have 0 is equal to ln of 1, because t is 1, divided by 1 plus c on 1. Now ln of 1 is equal to 0, so we are going to have 0 on 1 plus c, which implies that c is equal to 0. And so our particular solution will be given as y of t is equal to ln of the absolute of t on t. With our third example, we have to find the solution to the IVP t times y prime plus 2y is equal to t squared minus t plus 1, y of 1 is equal to 1. Here we compared this equation to the standard form of the first order linear differential equation, and so we must have this guy to be equal to 1. So we are going to divide through by t. Thus we are going to have y prime plus 2 on t y is equal to t squared minus t plus 1, all divided by t. and so we are going to have y prime plus 2 on t y is equal to t minus 1 plus 1 on t. Now we have the coefficient of y prime to be 1. We can compute p of t, and so we have p of t to be giving us 2 on t and g of t to be giving us t minus 1 plus 1 on t. Now let's find our integrating factor mu of t. Mu of t is defined to be e, the integral of p of t dt, and so we are going to have e integral of p of t is 2 on t dt, and so integrating this we are going to have e then 2 ln of t, which can be rewritten as e ln of t squared. Thus we have our integrating factor mu of t to be t squared. Our next step is to multiply through the given differential equation by the integrating factor mu of t, and so we are going to have t squared then y prime plus 2 on t y is equal to t squared t minus 1 plus 1 on t. So on the left hand side will always be giving us mu of t, which is t squared then times y of t, all differentiated with respect to t. Now let's simplify the right hand side. So t squared times t will be t cubed, minus 1 times t squared will be minus t squared, and the last term is going to be t. So we have to integrate both sides. So that's going to be integral of t squared y of t all prime then dt is equal to integral of t cubed minus t squared plus t dt. Thus we are going to have t squared y of t is giving us t exponent 4 on 4 minus t cubed on 3 plus t squared on 2 plus a constant c. And so y of t will be giving us, thus we are going to divide through by t squared, and so we are going to have t squared on 4 minus t on 3 plus 1 on 2 plus c on t squared. And so this function gives us our general solution, but this question was an IVP, right? So we have to find the particular solution. From the initial condition we have y of 1 is equal to 1, and so we are going to have 1 is equal to 1 on 4 minus 1 on 3 plus 1 on 2 plus c. And so we are going to have 1 is equal to 5 on 12 plus c. Now let's solve for c. So c will be giving us 1 minus 5 on 12. Thus c is equal to 7 on 12. And so our particular solution will be giving us y of t is equal to t squared on 4 minus t on 3 plus 1 on t plus 7 on 12 t squared. With our last question, we have to solve the IVP. T squared y prime plus 2ty is equal to ln of t with the initial condition y of 1 is equal to 2. Here, since the coefficient of y prime is not equal to 1, we need to divide through by t squared in order to get the coefficient to be 1. So we are going to have y prime plus 2ty divided by t squared is equal to ln of t divided by t squared. So we can simplify this to get 2 on t y is equal to ln of t squared. And so we have p of t to be equal to 2 on t and g of t to be equal to ln of t on t squared. Let's compute our integrating factor. Mu of t will be giving us e integral of p of t dt. So that's going to be e integral of, now p of t is giving us 2 on t, And so we are going to have this guy to be e ln of t squared. And so that's our integrating factor mu of t is giving us t squared. Our next step is to multiply through the given differential equation by the integrating factor. So we are going to have t squared y prime plus 2 on t y is equal to t squared ln of t on t squared. The left hand side will always be equal to mu of t, which is t squared in this case, then y of t, all differentiated respect to t, is equal to, so here t squared will cancel t squared, and so we are going to have ln of t. Now we integrate both sides. That's integral of t squared ln of t differentiated respect to t dt is equal to integral of ln of t dt. And so the left hand side is going to be t squared y of t is equal to, now we integrate the right hand side, that's ln of t, and the integral of ln of t is giving us t ln of t minus t, then we add our constant c. We now divide by t squared in order to get y of t, and so y of t will be giving us t ln of t minus t plus c, all divided by t squared. And so we are going to have ln of t on t minus 1 on t plus c on t squared. We had our initial condition to be y of 1 is equal to 2, and so we are going to have 2 is equal to ln of 1 on 1 minus 1 on 1 plus c on 1. Now ln of 1 is equal to 0, and so we are going to have 2 is equal to minus 1 plus c, which implies that c is equal to 3. So we substitute c is equal to 3 into our general solution, and we are going to have our particular solution. And so our particular solution will be giving us y of t is equal to ln of t on t minus 1 on t plus 3 on t squared. Thank you guys for watching. See you guys in the next video.